Alright, Shane is 61 feet high on a ride at an amusement park. The angle of depression to the park entrance is 42 degrees, which is labeled here. The angle of depression to his friends standing below is 80, this whole angle here. How far from the entrance are his friends standing? Round to the nearest foot. Okay, so basically we're trying to find this distance here. Because it says how far from the entrance, so from the entrance, is his friends standing. His friends are standing there. Okay, well the first thing we need to do is we need to be able to find all of the right angles that, or the right triangles that we need. Because we need right triangles in order to solve this. Okay, well here is a right triangle. And here, blue, is a right triangle. Alright, so if I knew some information about those right triangles, because I know I could find all that information because I have angles and side lengths, then would I be able to figure out the distance from the friends to the entrance? Yes, I would. If I knew this length here, and I knew the full length here, all I would have to do is subtract, and I would be able to get just this length, which is the length we want. So that's exactly what I'm going to do. Alright, I got rid of some of those stray marks for us so we can identify things more easily. Alright, so we know that this is a perfectly straight line. Based on the definition of angle of depression, means from going straight. That means what we know is a straight line, obviously, but I mean it's going at a perpendicular angle to this. So that means that we know the full angle is 90 degrees all the way from here to here, which means that this little part, this angle, must be 10 degrees because it's 80. So this must be 10. Okay, so 10 degrees. So now we know an angle inside this right triangle here. And here, I'm going to redraw it over here. This is 61, this is 10 degrees. And we're trying to find this right here, we'll call it x. Well, x is opposite of the angle, so it's the OPP. And this is adjacent. It's definitely not the hypotenuse because it's not across from the right angle. Alright, so we know that the thing that deals with opposite and adjacent is tangent, based on SOHCAHTOA. There's opposite, there's adjacent, TOA, tangent. So the tangent of the angle, 10 degrees, is going to be equal to the opposite over the adjacent. It's always the first over the second. So it's going to be x over 61. We'll multiply both sides by 61 to get rid of what's on the bottom. So this one's going to leave x by itself. And we do 61 times the tan of 10 is 10.76 is how we would round that. Okay, so now we have this distance here is 10.76. Now we got to know this whole distance all the way across so that we can find the distance from the friends to the entrance. So we have to identify the other right triangle in this problem, which is right here. Alright, now this time we're going to have a different angle. This whole thing is still 90 degrees, so we have to just subtract 90 minus 42. That gives us this angle is 48. So I'm going to redraw that. 48 degrees here. Now this was already 61, and we're trying to find this, which we'll call it x. Again, this is opposite and adjacent, so we're going to do the tangent of the angle. Remember, it's always tangent or sine or whatever of an angle is the opposite over adjacent. Multiply both sides by 61. Get x by itself, and 67.75. So now I know this whole distance here, and all I have to do is subtract this value minus this value to find the distance from the friends to the entrance. So 67.75 minus 10.76, and be something 56.99. I just typed it in my calculator. There we go. And we just got to figure out the units, feet, instead of in the problem. So it's 56.99 feet, about 57 feet. It says round to the nearest foot, so there, perfect. 57